Folks, on problem 1020, we did discuss the last value method, then the averaging method. Now let's go on to the moving average method. Now this moving average is based on, okay, now what is the difference between the averaging and moving averaging? Okay, now averaging, if you go to that one and then double click on this. Okay, now it is going to take the average of last 11 months to make a forecast for December. Two things. One, what happened way back in January might not have the same influence as the recent most things that are taking place. It may not have that one. Okay, so that's one drawback with the averaging. And the second one is, even if you were to go with averaging, so for each product you had to have the data for about 11 months. So literally a company has hundreds and hundreds of different products and subcomponents, and the requirement on database would be huge. So that's the drawback with the average. Okay, one, why should an event that happened way back have the same kind of effect in terms of, because we are simply taking an average that happened last month? It should not. So this should have less prominence, and the recent most should have the more significance on our prediction. So moving average kind of addresses that to some extent. In the moving average, we take the average of based on how many periods, 2 periods, 3 periods, 4 periods, something like that, that would be given to us. So now with this problem calls for 3-period moving average, meaning that the first month that I can make a prediction is I had to have 3 data points. That is going to be April. Okay, so moving average is the average of the last 3 actual values. Okay, that's the average. Now when you copy the command down here, when you click on the forecast for May, then would be as soon as the April data is available, that comes in, the oldest data January is left out. So we go for the last 3 periods average as the forecast for the following month. Now since we are taking average and we are moving along with the time, like in this case including April for May and discarding January, so we move along with the time. That's the name moving average. Okay, so let's copy the command down all the way. Now sometimes people do take 2-period moving average or 3-period moving average or 4-period moving average. Then in that case the earliest month that we can make a prediction would be May, if it is 4 weeks. So what is the difference? See, if we do a 2-week, 3-week moving average like that, lesser the number, our reaction to the environment or market is much quicker. Okay, so if we take 5 or 6, 7 periods data as an average to begin to predict, our response is sluggish, so we lack on that one. But our prediction, the curve would be a more smoother curve because we lag that, and then our response is little sluggish. Okay, so that's the reason. Folks, okay, just like before, the way that I did, I have filled up the columns here because it's a repetition of what I did for last value method. Averaging method is the next one, is to compute the the error, which is the absolute value of the difference between actual and the forecast. We take only those terms for which we have both information, that's actual as well as the forecast. Okay, then copy the formula down. Okay, copy the formula down. So then you populate this column. Okay, then the percent absolute error is the ratio of the error to the actual value, and we do it only for, again, that data for which we have both information, actual as well as the forecast. And these formulas were similar to what we had before. That's the average of that one, and MSE is the average of the sum square of these errors divided by the number of error terms. That's what we have as before. Mean absolute percent error is nothing but this is the percentage of error for each period. The average of those is what is given here. Now the last method that I want to discuss under the time series tools that are available for forecasting is exponential smoothing. Of course, there are variants to this exponential smoothing. What we are looking at is simple exponential smoothing. The other variants are adaptive exponential smoothing, the exponential smoothing adjusted for trend, so those things. Okay. So what is exponential smoothing? This is by far the most effective and I would say the forecasting methods of all that we have seen. Okay, the last value method just looks at the recent most information, just the last value, and ignores the rest of the history. Averaging method looks at the entire history and assigns the same weight. Moving average, what it does is, it does assign the weight for the last few quarters and forgets about the oldest piece of information. So exponential smoothing is the only method that has that institutional history. It does have, but only only the data requirement is that you got to have the two pieces of information all the time. So that way the data requirement is less, but at the same time effectiveness, this is the highest. So that's why it is one of the most popular method that's used, exponential smoothing. What is exponential smoothing? The forecast for the following period or the forecast for the current period is alpha. Alpha is the smoothing constant, okay, times the last value. What was my actual sales yesterday? In other words, forecast for today is my actual sales that happened yesterday. Take a portion of that, because that's the alpha, whose value is between 0 and 1. So we take a portion of that, then 1 minus alpha times the last forecast, meaning that my forecast for February would depend on what was my actual sales for January and also what was the forecast for January, and take a weighted sum of those two, and that weight depends upon the alpha, which is the smoothing constant. Okay, now if you look at it here, now we can go back last value and last forecast. We can use the same formula. Instead of the forecast, we can put the last forecast. Then this is going to be over here for the last forecast. Go back and use the same formula. Then it becomes, this part would become alpha times the value before the last forecast plus 1 minus alpha times the value before the last forecast. Okay, so that way you can continue this. Okay, so in other words, we can express the forecast as the alpha times last value plus 1 minus alpha squared times the value before last value plus 1 minus alpha cube times the actual value 3 periods before plus 1 minus alpha to the power of 4 times the actual value 4 weeks periods ago, etc. See, that's that regret. If you keep on substituting using the same equation, we get that. In other words, the alpha plus 1 minus alpha square plus 1 minus alpha cube plus 1 minus alpha to the power of 4. See, those are the weights. They fall off exponentially as the data gets older. So this is the latest time. This is the time goes back into the history. So we do remember that, but we keep on assigning a smaller weight as we move forward. So the institutional history is remembered, but less and less weight is placed to the oldest data and a higher weight is placed to the recent most data. So that's exponential smoothing. Okay. Now for this problem, to make a forecast for February, we need alpha, that is the actual value, let's say actual value for the January plus what was the forecast for January. Now here always you do take a beginning assumption. In the problem this is given to us as 120. Okay, now let's use this formula here. Alpha times alpha is a constant, so that, and I'm going to precede that with the dollar signs. Dollar and dollar, because this is constant, times the previous value, that's actual sales for the previous period, plus 1 minus alpha, and again alpha is constant for all, fix this position, times the forecast for the previous period, which is that. Okay, that's the formula. Now copy the formula down, then go and then find the error again as the difference between the absolute error as the difference between the actual and the forecast. Go and then populate that column as we did before, and also calculate the percent error as we did before. So I'm going to fill up these two columns. Next. Okay, folks, let's go and then let's compare all these 4 different techniques that we have discussed so far. Let me copy for the moving average based on the mean absolute deviation, MSE and MAPE, what those are. I'm going to go copy, then I'm going to go to the last sheet comparison where I already had the other 2 values. Here I'm going to go click it, and I'm going to do the paste special. Paste special means only the values, not the formula, because I'm on a different sheet. If I just go and use the current paste, then it's going to look for the formulas and it's going to return an error there. Okay, I'm on a different sheet, so that's why I'm going to go for paste special. Just paste special, just the values. We don't want formulas. Okay, that's that value. Click OK, and they get here. So let's express that into percentage, and of course 2 decimal places. And now let's go for the exponential smoothing. Let's copy the same thing. Copy. Go to the comparison sheet. Right click, paste special, just the values, and populate that and express that as a percentage to 2 decimal places. Now this gives us. Now, based on the MSE, MAD and MAPE, the one that has the least is the method that you want to go for. Okay, now in this case, for the last value method, the mean absolute deviation is 5.27, and for averaging method it is 10.03, and 8.11 under moving average. Exponential smoothing is 18.49. Okay, so based on this characteristic, and of course it also has the least in terms of the other one too, so you would basically go with the last value method. So our decision would be to go with the last value method. That seems to be the best method in terms of this statistics that we have.